This video is sponsored by Rewarded View. Are you tired of just scrolling through your phone without making any profit from it? Well, Rewarded View is for you. If you have an Android phone, then head over to rewarded-views.prima.ai, download the app, and start earning today. All you have to do is create your account, watch videos, and get paid for each and every video that you watch. So, what are you waiting for today? Download Rewarded Views and earn the smart way.
Hey guys, how y'all doing? How's your day going? And if you're just starting out your night, hope you had or are having an amazing and a beautiful day today. Today we're going to be talking about Matplotlib, which is one of the visualization tools that Python provides. It's a model. It's very easy to use. In our next video, we're going to touch a more advanced version of it, which is Seaborn. But for now, we're just going to be briefing through Matplotlib. So first things first, if you wish to donate now, because the link is also going to be provided for you. But first thing, you need to install the model by doing pip install matplotlib. After you've installed it, you are going to import two things. The first thing is to import matplotlib.pyplot as PLC. We already covered models. Importing this numpy is not compulsory though, but I'm using numpy to generate certain data that I'll be using to plot the graphs. But if you want to manually create those data, you can do so. And now let's just see how working with matplotlib actually works. So we have two data sets, which are two lists of equal shape, and we're going to just say plc.plot, pass our a as our x and b as our y, and it's going to plot a beautiful graph for you. Now, if I want to just use numpy's range to develop to plot our graph, we're just going to say um np.arange equals to we're starting at 0, stopping at 10, and we're going to be skipping after every 0.5 count. And then x is going to be v, y is going to be v square, and this is the graph. Now, this fancy line over here, this text of strings, if you want to remove it, you just simply do plc.show parentheses, and you should get rid of this text if you don't want it. Now, to customize our graph, make it look more presentable, for starters, if not add a title so that people would know what you're actually talking about, you can do so by just doing plt.title parentheses inverted in and inverted enclosing an inverted comma what the title of the graph is, which in this case is a simple graph. And I think at this label each axis, so these are y, these are x, but let's say I want to, this y is like total grades, I want to add it. We'll just say plt.x label. I'm just using x and y, plt.y label. I'm just going to put y, going to put x. Customizing the tick. So this individual value here, like this 1, 1.2, all sorts are tick. So what if I want my ticks to, instead of being 1, 1.2, I want to be maybe 1, 2, 3, 4, I'll customize my tick. So to customize your tick, you just say plc.x ticks for which one you want to customize, and you just put your custom counts from where you want to start to where you want it to end. Likewise for y and legend. So legend allows you to add more like visual customization to your graph. So when you are plotting the graph, there are more arguments you put, like the color, the width of the line, markers. Like when you are plotting graph normally on paper, you mark each point, then use the ruler and roll across where the points are meeting. So that is the marker here. So you just choose what sign you want to use to mark it. You can go to the documentation to see what is allowed to be passed here, or you just put marker, which is this stuff I've seen over here. The size, the line style. Also go to the documentation to see what line style is allowed, and the label, which is going to be like the individual name for each line. Let's say if you are plotting a graph that has multiple lines, you just add a label for each one. But after you're done, just put plt.legend and your graph is going to come out looking something like this. If the size of your graph is not presentable enough for you, then you can resize it by just simply doing plt.figure parentheses fixed size equals to the new size you want, and you can just customize it until you feel it looks good enough. If you want to share your graph as an image, you just do plt.savefig parentheses file.png and your DPI, which is the dots per inches. I'm not really sure how the measurement of that works, but just wherever you pass, and your file is going to be pasted. I think it's as follows. And if you come over to file.png, you're going to see it. Yeah. Mm, yeah. Now, the actual plotting of more graphs, not just normal straight graph. Let's just put it in bar chart. So, bar chart is usually when you want to compare length, like data together. So let's say we have A, B, I want to just plot graph. Let's say bar chart where it's just to plot the BR, parentheses A, and B where A is your X and B is your Y, and just look at something like this. Now, if you want to customize it, so these are stuffs are usually called active. If you want to customize it, you can add custom patterns. So it's just going to be for this. We are not just going to plot. We're going to equate this plot.br to a variable, and we're not going to call that variable. And since zero is distance from one, and this is two, so just do step underscore hash, and we're going to pass an argument. So then again, go to the documentation to see what argument you're allowed to pass there. But this is how it's going to look. You can also do the exact same thing for colors by saying set underscore color RGY, and you can check the documentation for more color alternatives. Now, what is fencing bar chart versus an histogram? A bar chart is used to compare data, usually to different ones of different categories, while a histogram is used to visualize data distribution across a single data. Let's, for example, bar chart could be like, okay, I can say student A, student B, student A got 80, student B got 90. So this student A is going to be here, student B is going to be here. That is what my bar chart to look at. But histogram is going to be more like, I have a bunch of students that got a spread of scores from maybe 0 to 100. Now I want to see how many students got each of those scores. So I'm going to check like how many students got 80, how many students got 70, how many students got 60. If that's the answer I'm trying to get, then I'm going to use a histogram. So plotting a histogram is going to be just I'm just generating a random value here. You can use your own value if you wish. But I'm going to say plt dot hist bracket. I'm going to pass my data. So your value should be stored in that in an array or a list. I'll just pass that here, and this is going to plot it for us. So these stuffs are called beans. Beans are kind of like, let's say, let's use the school results. We have students who are getting anywhere from 0 to 100. I can also group them into beans. Like I can say 0 to 10 is the first bean, 11 to 20 is the second bean. So within that 0 to 10, we could have like maybe five different students that got anywhere from 0 to 10. Do you understand? So if I want to customize the bean, there are two ways I can do it. I can either say I want to have 30 different beans. The system will find a way to distribute it in the way that at the end of the day I'm going to have 30 different beans. So I'll just say data, which is the array, then beans equals to 30. I'm just adding this edge color so I can see where the lines stop at. Another second way is if I want to like manually divide it. I want to say for this first one is going to start at -2. Like let me use a more better example. Let's say for example I'll say I want to manually group it up. The first one will be from 0 to 20. So I'm manually distributing the beans myself. Just these two ones, group them as ones, two ones, group them as ones. It's usually better when you are doing something where you want to have control over how things are split amongst different groups. So once you do that, if you're doing this, you just say it's almost the exact same thing. But instead of saying beans equals to a number, you're just going to say beans equals to this list of data you split, and this is how mine is going to look. Lastly, let's touch scatter plot to generate my random value. Plotting a scatter plot is very easy. Plt.scatter x y is almost the exact same thing. Plt.bar, plt.hist, plt.scatter. This is how a scatter bar will look now. So we're just going to take visit two arguments. The first one is size. If you just generally want to increase the size, just say s is equals to the new size, which will just increase the size for you. But if you want to increase the size conditionally, let's say for example I'm having two arguments x and y, and let's say y is maybe age in this case, and I want based on what the user's age is, the higher the user's age goes, the higher, the larger the scatter plot point is going to look like. So I'll just say s is equals to y, and it will look something like this. The line is a little bit too tiny, so just ignore for now. Secondly, if I want to color the scatter plot, I'll just say C is equals to green. And likewise, like I did for size, if I want to the colors to differ depending on maybe the age. If age was y, I'll just say c is equals to y. But this one, like, just looking at it, I may not really know what each of these different colors signify. So I may want to use like a color, a specific gradient that just in the color intensifies as it increases. So I'm going to do that. I'll just say c map equals to greens, and it's going to look something like this. And for to make it easier for people to understand, I will just add a c bar, a color bar. So it's going to be just c bar is equals to plt dot color bar. C bar is just a random variable, it can be anything. I'm just going to say c bar dot set label into parentheses highest, that people will know that like, it's going from lowest to highest. So you can give any name that fits. But yeah, that is all for now. Matplots is more of like a base, so just the basics. We're going to visit more complex things like joint plots. We're going to start seeing KDE regression lines. So if you are interested in that, in our next video, we're going to be touching that, where we'll be talking on Seaborn.